All right, let's jump right in. You've probably spent a ton of time learning how apps get attacked, how to find those tricky vulnerabilities, and of course, how to write secure code to stop them. But now it's time for the final piece of the puzzle. We're going to flip the switch, stop thinking like a developer, and start practicing security by thinking like a reviewer. That's the big question. How secure is your code, really? It's so easy to write something that works, ship it, and just move on to the next thing. But there's a huge gap between it works and it's secure. So in this explainer, we're going to walk you through step by step how you can start to close that gap by doing your own mini security audit. So the very first thing we have to do, and honestly, this is the most important part of the whole process, is to make a fundamental shift in our mindset. Now, what I love about this slide is just how clearly it lays out these two completely different worlds. As a developer, your entire goal is to build, right? You're focused on functionality, and the number one question on your mind is, does it work? But as a reviewer, your goal is to break. Your focus is hunting for vulnerabilities, and you are constantly asking, how can this fail? For this audit, we are living and breathing in that second column. Okay, so where do we even begin? The key here is not to try and analyze your entire application at once. That's just a recipe for getting completely overwhelmed. Instead, we're going to pick just one small, critical feature, and we're going to go deep. And this is what we call a mini security audit. You can think of it like using a microscope instead of a telescope. We're not trying to look at the whole galaxy, we're deliberately narrowing our vision to get an incredibly detailed view of one specific part of the system. And that focus is what makes this so manageable and so powerful. And these are just perfect candidates for that kind of audit. Things like a login flow or a password reset. These are high-value targets for any attacker. For our case study today, we're going to zoom in on a classic and often very vulnerable feature, a file upload endpoint. All right, we have our target. Now it's time for the fun part. We get to put on our attacker hat and start probing for weaknesses. And to make sure we're effective, we're not just going to poke around randomly. No, we're going to follow a structured step-by-step plan, and this is how we stay on track. A simple checklist like this is our roadmap. It makes sure we don't miss the major categories of vulnerabilities. Just think of them as the 3 chapters of our investigation. First, how does it handle stuff users send it? Second, is it checking who's allowed to do what? And third, how is it protecting the data itself? So let's hit our first checkpoint and see how this works in practice. Input handling. The feature is supposed to let users upload a profile picture, and an attacker's brain immediately thinks, okay, but what if I don't upload a picture? What happens if I try to send you a malicious script, but just disguise it as an image? Now, if the system doesn't properly validate that file type, the risk is huge. We are not talking about a small bug here. The potential impact is remote code execution. That could lead to a complete system compromise. This is basically a game over scenario for the application, and it all started because we trusted the user's input. All right, on to the next item on our checklist, authorization. So let's say the system actually handles the file upload perfectly. The attacker's not done. Their next question is, okay, cool, my file is on your server, but can I see everyone else's files now? Is the system actually checking who I am before it lets me download something? And if the answer to that question is no, well, we've just found another critical vulnerability. This is often called an insecure direct object reference, or IDOR. The risk is that there are no permission checks, and the potential impact is massive information disclosure. We're talking about a full-on data breach where you could be leaking sensitive user data to absolutely anyone who figures out the pattern. So here's the crucial thing. Finding these issues is awesome, but it's only half the battle. To actually make things more secure, we have to document our findings so clearly that they can be easily understood, prioritized, and, actually fixed. A finding is pretty useless if no one acts on it, and this slide just perfectly illustrates the difference. Simply writing authorization issue. What is that? It's so vague, it's not helpful at all. But a strong finding, that's something you can act on. It tells you exactly what the problem is, why it's a problem, and where it's happening. A finding this clear makes it obvious why it needs to be fixed right away. See, a good review always connects the analysis directly to an action. Based on those critical risks we just found, we can make these super clear, concrete recommendations. First, validate the input. Only allow specific image types. Second, enforce authorization on every single file request. And third, sanitize those file names. Each one of these recommendations directly slams a dangerous door shut that we found wide open. Okay, so we've just walked through the entire process on a sample feature. We shifted our mindset from a builder to a breaker. We picked a focused target and we used a simple checklist to find and report critical security risks. And now, the power of this process is in your hands. You can read about vulnerabilities all day long, and that's great. But actively hunting for them in a structured way, that's how you really build the skill. This is how you go from theory to practice and make a real-world difference. So I'll leave you with this final thought. Think about the apps you work on. Whatever it is, that's your target. That's your starting point for practicing security.